like to introduce to you tonight Liebergot.
What I'm going to do tonight, this is what was requested. I got a number of talks I'm going to give, and what I'm going to do tonight, I'm going to guide you through the unfolding failure of the Apollo 13 cryogenic oxygen tank explosion. And you know, as I was there last hour of my shift, and I'm going to show you and guide you through that using the actual data screens on my console. It just so happened that I had we had a little button to make hard copies of our whatever we had on the display. And of course, the time was on the display. And so I just cranked off a bunch of copies because I needed to have them possibly for testifying. Well, when PBS came down here, we had a graphics person redo them, as you noticed, so that they were clear and clean. So you'll be able to see the clear and clean version of it. And they are all in the appendix of the book here, so you can follow through these, as well as the chronology I'm going to take you through of the tank history. And you're just going to shake your head and hear what the actual history of those two tanks are. Anyway, and that'll be what we call how the data played. This.
We got one problem. Okay.
First 10 seconds. I just let you want to hear that. Not a good time. Not a good time. Didn't want to show you that one. That was that's the anatomy failure. This, if we can make it come out right, this is probably too much for this. This is a Saturday. Never got to see one. Always in the box. That was my unrequited desire. I did go down, I was assistant flight director in Apollo 4, 501. I weaseled my way down there and actually climbed to the very top of the first Saturn V we ever flew. And let me tell you, 425 feet is pretty tall. I mean, that's on top of the launch platform. So, I know you've all probably seen the movie, the great Ron Howard movie that did us such a favor because it revitalized people's interests in 1995 in our space program. And I remember reading reports of people young people standing and applauding. Not bad, but you got to keep in mind when I'm asked how accurate it was, you say, look, the guy was making a drama. He was not making a documentary. Documentaries are a lot cheaper, I think I found out. And he took a lot of artistic license with it. And one of the artistic licenses he took was to cast his brother, Clint Howard, to portray me in the movie. And you'll have to admit he took a lot of artistic license. We're friends. We became good friends as a result of that. And but this is probably the first prime example of artistic license that I can take. Anyway, it's going to be a little tough to see this. I'm going to do it from here. Let me give you a primer on what the command service module was. You'll need to have this. I'm going to use the cursor. I think this will work. Right? Yeah, there you go. Command module is up here on top. The service module that contained the tankage for the big SPS engine and the fuel cell, electrical fuel cell power plants, and the oxygen and hydrogen tanks. All this stuff was truly a service module to supply to the command module. Here's the high gain antenna that we got our high fidelity or high bit rate data. And then on top of this is the launch escape system, which we were testing to the Orion. It's huge. This launch escape system, now called launch abort system, was copied by the Russians, and they were the only ones that ever used the copy. They actually did a pad abort using the copy they made of our. And later on, I understand that the cosmonauts thank our astronauts for the design. So that was pretty good. The system was capable of taking up 2 miles and out 2 miles. It was very powerful, and the crew pulled 16 Gs in about 3 seconds. You know, they could Nestled down in the spacecraft LEM adapter was the lunar module on top of the S4B. So at least you have that. I'll get through this in a hurry. Now here's the inside of the service module. This is important. Oops, don't want to do that. You can see the 3 fuel cell power plants are in this little vertex Griffith segment of the top shelf. Underneath is underneath is the oxygen tank number 2 that was the one that blew. The explosion impinged the fuel cells up on top and killed them. Oxygen tank 1 is buried back here in the V, and it's from the leak 2. The 2 oxygen tanks, of course, were not involved. So this way you can see what all that was about. The tanks were done on a shelf as a tank set at Beach Aircraft. And they could just slide them in, hook them up, and you're good to go. You can see all the tubing that was close by to the 2 tanks. So when tank number 1 went, it affected the tubing to tank number 2, tank number 1 rather. So that's how that was made. Here's the actual fuel cell power plants. Here's fuel cell number 3, fuel cell number 1, number 2, number 1. And these 2 died. The one back in the back didn't get impinged by the explosion of tank number 2 down below. Luckily, otherwise we would be dead in the water quickly. So this one was hanging on by a thread. And of course, here's the 2 oxygen tanks. Here's oxygen tank number 2 that blew, and right behind it is oxygen tank number 1. Here's what the tank looked like. This is important to know. Tanks are very, very efficient, by the way. Here, let me. When we did a cryostart, the switches are thrown on the main display panel in the command module, and turned on these 2 fans in this heater core. The heater core was there to pressurize the O2 or the H2 to get it out of the tank. In the middle here was this capacitive gauging system that ran the whole length of the tank. There's a tube within a tube. The cryo was the dielectric, and the material in the tank had to be homogeneous, otherwise it would stratify in different layers at different density, and we would get fake readings. So once a day, when the crew woke up, we would stir the cryos. Give you an idea how great these were. By the way, we considered the tank's structure. Structure had a reliability of 100%. Didn't work this time. Our astronauts had a reliability of 100%. I don't think we give that to them nowadays. But here's some gee-whiz stuff about the tanks. In order to maintain their contents in a liquid state for up to 2 weeks under varying external temperature conditions, the tanks had to be well insulated. You can see it's a double wall. In fact, they were so well insulated they could have held water ice in its frozen state for more than 8 years at room temperature. So, pretty good. They were also extremely well sealed to ensure low leakage. That we did deep leakage. Apparently, the equivalent leakage rate would flatten a typical car tire in about 32 million years. So, they're damn good tanks. You'd want to keep your hot coffee in them. This is just a gee-whiz chart, and I'm not going to bore you with it, but what it shows is that we separated the main buses, main DC distribution buses. We had fuel cells 1 and 2 were on AC, on main DC bus A, and only fuel cell 3 was on main DC bus B. And that's you'll hear level say we had main bus B not roll. And that's because the fuel cell died, there was no voltage there. But we kept them isolated that way. Main loads were on main bus A. So that's what we did there, and that was good planning on our part. So, where am I going with that? So what's an econ? Okay. Well, I should say, what was an econ? It turns out I was giving a talk to some young flight controllers, and they're doing away with the title flight controller. They decided to merge the training people, in a lot of cases were smarter than we were, with flight control people, and get rid of flight control name. So the entry level of certification is now operator, operator console, I guess. The next level up was specialist, and then the final, the supreme level is trainer. So I said to the guy in charge, I said, why don't you just put the flight controller adjective in front of those three titles, and you have flight controller operator, flight controller specialist, and flight controller trainer. Why don't you just do that? Well, still a game about it. If it's not new, then it's not worth it. We just changed it because we felt like it. So when I got done talking to these young flight controllers, it was very clear that they didn't want to give up the tradition of being a flight controller or flight operations person. So who knows where they're going to go. So I wrote, so what was an EECOM? Well, I'm one of the last ones. It was an acronym that was introduced for the Mercury program. It recently stood for Electrical, Environmental, and Communications. I actually had communications at my console too. What a burden. We finally got rid of that, but it's a historic radio call. It's very recognizable on the radio, and the E sound really comes through. And I was a EECOM flight controller. I wish I had those glasses back. Well, I love those glasses. I gave away the house for the blind or something, lighthouse for the blind. Anyway, I was a EECOM flight controller throughout all of Apollo. Skylab, I was Eagle. See the Eagle up there, console. AST, and even early shuttle. And when I got the shuttle, I said, I don't have it in me to look at data. The spacecraft just going around. So I retired from that. But the EECOM position in the Mission Operations Control Room, which you pronounced MOCR, MOCR, now they call it thicker, Flight Control Room, is steeped in tradition. I said men, it was all men back in those days, who sat at the EECOM console during Apollo inherited the standards of professional behavior and performance that gave newcomers to the position some pause. It's what we had to know and how we had to behave ourselves. It was a lot to live up to. Ongoing Gemini flights and the addition of Apollo operations require training of additional EECOMs, such as myself, subjecting us to a real steep learning curve. We had to learn a lot in a big hurry. The EECOM flight controller was responsible for monitoring and responding in real time the health and the critical operation of all the critical life support systems on the spacecraft, and which amounted to roughly half of all the systems spacecraft. And they included all the electrical power and distribution, the heating and cooling, cabin atmosphere, pressure control, breathings, oxygen, cryogenic oxygen and hydrogen for the fuel cell electrical power plants, the sequential event control system to control our separation, parachute deployments and stuff like that, and many of the mechanical systems. We just had to know a lot. And we were also responsible for the CSM communications through Apollo 10. But what happened on Apollo 10, when we were trying to, or lunar orbit, trying to separate the lunar module from the command module, CSM, we couldn't do it because we didn't have communications between the two spacecraft. Stafford and Cernan were in the lunar module trying to communicate with Ron Evans, the command module pilot, and they couldn't do it. And of course, Stafford was cursing up a storm. Most of us never read. It turns out there was one communication switch out of position in the lunar module. And so Gene Kranz, our flight director, all knowing, all seeing, said, we're going to take all the communications for everything and put it in one integrated console called INCO. And boy, what a move that was. It was just wonderful. It was a difficult system to learn. I mean, most of our astronauts didn't know how to operate the communication system on spacecraft anyway. Anyway, so with all that, but keep in mind, my degree is in electrical engineering, but all the systems that I recited to you, degree means nothing. It just means you can learn. And I had to learn an awful lot. I became a systems flight controller. I love systems engineering. You tend to learn somebody else's design and then point out what's wrong with it and how they ought to fix it. It's a great discipline. Anyway, the flight directors, knowing that how much knowledge we had about the whole spacecraft, because our systems went everywhere. Now, they saw the EECOM as a catch-all. If a function didn't fit somewhere, then it belonged to EECOM. And EECOM was willing to take responsibility for all situations and anomalies not claimed by somebody else. That's yours, isn't it, EECOM? Was a common flight query. Because EECOM was required to develop a broad understanding of everything in the spacecraft. We had a thing in there called sandbagging. A lot of you probably know what that is. That's where if something occurs in your area, in your area of responsibility, but you don't want to tell anybody about it at that time because you look bad. So what you do is you wait until somebody else says, "Hey, I got a problem, flight," and you come in and say, "Oh, by the way, I've got a problem too." Sandbagging was a popular game at the Cape for launch. The command service module guys and spacecraft guys would have funnies occur, and the booster guys, who were most critical, was sitting there, and of course they knew they had to speak up first. And they'd be sitting there waiting for somebody. It's a game of chicken, launch chicken. And they'd sit there waiting for somebody to speak up first, and more than once we've heard the booster guys finally have to give in and say, "We got to hold the count because we got a pressure problem in one of the tanks or whatever." And then the CSN guys are going to say, "Oh, by the way, we got about 3 or 4 problems that we've been working on, we just have to tell you about." Sandbagging. And I've been sandbagged more than once by a guidance navigation controller, GNC, who sat to my right, who would not speak up unless I spoke first. And since I had a general knowledge of the whole spacecraft, it was my tradition to speak up for his system. He said, "Oh yeah, Flight, we were looking at that." Sandbagging, remember that. Do sandbag somebody else if you get an opportunity. Anyway, we monitored the health of the spacecraft system by several methods. By examining the real-time data displayed on each CRTs. Let me change this. Eye chart. I'll show you more about that. We had 2 CRTs in front of our console. On Skylight, we had 3. And 5 people supporting me in the back room. It was a mess. Too much data. And not a real modern way to process the data, to sort it out for you like we have now on Skylab, on Shuttle, and on the station. So I used the data to look at. My backroom guys had other more detailed displays to look at and computational capability. And they were more expert in a couple of systems. I had a broad knowledge of all of them. And what we had I had 2 console displays. One was called the I guess you could read that right, CSM Environmental Control System Cryogenics tab. The other one was called the Electrical Power System High Density for no other reason than it was loaded with data. And what you'll see here, down here, and the ground elapsed time is at the top, 55 hours, 46 minutes, and 53 seconds into the flight, and the electrical power system had the same timer. And there's cabin pressure and the cooling loops that cool our equipment and kept our astronauts comfortable. And at the bottom here is the cryogenic supply. You have O2 tank 1, O2 tank 2, hydrogen tank 1, hydrogen tank 2. H2 and O2 fed into fuel cell power plant that has a KOH in there as electrolyte, create electricity and pure drinking water. What a great deal. Couldn't answer it. And that technology has been around ever since then. I just want to point out down here at the bottom, the pressure normally ran in the oxygen tanks ran about 900 psi. There's 1 and 2. At this point, we're down to about 77, 78% quantity. This represents 101%. Now, what happened was about 47 hours into the mission, the quantity sensor of oxygen tank number failed. It just, a wire opened up, who knows. But it was no problem because we always fed the tanks down together. They were manifolded together so that if one tank's data went out, we could infer the data for that tank we had no information on from the other tank. We always kept them within a couple of percent of each other. It's called cryobalancing. On the other tank, on the other display, electrical power display, you'll see down here we were charging a battery. We had 3 little entry batteries that were 40 amp hours apiece. smaller than your car battery, by the way. And here's the charger current at 1.12 amps. Now, main bus, DC bus A was fed by the fuel cells. Main bus A fed AC bus 1, all the rotating machinery, stuff like that. Main bus, DC bus B, through an inverter, fed AC bus 2. The reason I tell you that is, if you lose main bus A, then you lose AC bus 1, and you have a whole cascade of equipment that's failing. And if you weren't watching it, you didn't know where it started. And that's what happened on Apollo 13, the cascade failure. But this was just a nominal representation to you. We're probably more fortunate than the Russians because each of the data were sampled on board at 10 samples per second and sent down. Because of the limitations of our computing ability on the ground, we had to squeeze that down to 1 sample per second. So our display is updated 1 sample per second. And you say, well, that's not good. Well, it is good. When I went to Russia during ASTP, I was looking at this little 19-inch screen they had up. They had, I don't know, 15 lines of data. The numbers were that big. And I said to the guy, I said to the Russian, I said, how often does your data update? He said, oh, once a minute. Oh, excuse me, you're really making decisions on once a minute. So we were far better off than our Russian counterparts were. And I'll have to show you this. Since it was impossible to monitor each and every parameter, we had, I'll use the screen, we had what we call limit sense lights, a lot more on Skylab. And the little lights would light up. We would preset the limits on it, not to show a failure, but to show a change. We have a band. And that would draw our attention to the screen where a little asterisk would show up next to the parameter that decided to change for whatever reason it was. So, and these consoles got pretty hot when I would roll those little lights. But that was everything was hardwired. No computer-driven stuff. The only computers we had was in the first floor of the real-time computer complex that IBM owned. Big mainframe, 360-75s, and they thought they were God. We had a lot of problems with those people. Do you want to change the light parameter? You'll have to submit a form. And we don't do that anymore, right? Anyway, so I get to think a little bit when I talk to you guys about the data. Anyway, so the first 7 hours of my 8-hour shift had drifted by. The crew had done all the things they were going to do. Jack Lausman radioed the crew that the spacecraft was in good shape as far as we're concerned, and we're bored to tears down there. That was going to change. You did last time anybody would mention boredom for a long time. This is the Moker, MOCR. I just happened to find this picture. It's about 5 minutes or more before the oxygen tank blew up. Very significant. Fred Hayes just finishing with Jim Lovell their inspection of the lunar module the first time. You can see we're on translunar coast on the big 10x20 screen. Here's your leader Kranz, as we call him, or General Savage. Jim Kranz. Done a lot of things, but let me tell you, he was a true leader. True. I mean, the Moker was pretty deserted. Here's the back of my head when I had lush black hair. I think we're gonna have to say that. I'm leaning back, probably smoking a pipe. Buck Willoughby, my guidance navigation control counterpart, was here, probably smoking his pipe. And we're kind of watching the TV show. And here's Jack Lausman at the Capcom console, astronaut who flew on STS-3 and Skylab. And he just sit back watching the show, and everything's cool. Here's Vance Graham sitting here, nobody around, not even the press. Because the press decided after only 2 landings on the moon that was old hat, and nobody had it. Yeah, you guys weren't interested anymore. So I call this my everything is under control picture. And here's some of the.
So like a verification of the docking angle, because that's what we'll be using.
That's great.
Alignments and everything else. See if
shift. We're putting the crew to bed. Certain things you want to do before they went to bed. The next team would come in, babysit the spacecraft until the crew, the 7th hour of their shift. The crew would wake up, go through some post-sleep checklist items, one of which was to stir the cryos. I asked for an extra one, though. not a good deal. So now, I'm going to show you the way the data played. And I've already explained to you one of the things that we're doing. Let me get the display up. One of the things we were doing was we were balancing the quantities in the 2 hydrogen tanks. We did that by shutting off the heaters, the automatic heater pressurization control in the high tank, in the low tank rather, and left the automatic heater pressurization control for the high tank on. So we would feed mainly out of that tank and bring its, we brought the quantity within 2.5% of the other tank. We would go back to full automatic. Well, every time the tank got below a certain pressure, it would set off the master caution warning alarm on board. It would light the cryo press light. The crew would say, "The master alarm, let me look at my panel. Oh, it's a cryo press light. Something's going on with cryo." Well, they knew that it was no problem because we were doing this tank balancing thing. And the only trouble is that the cryo press light was an OR gate of about 8 parameters, any one of which would light the light and lock out all the other parameters, like O2 tank 2 overpressurizing. So that's the reason I wanted to show you that. Okay, so that's enough of that one. And you can see the time was 46:53, and this was, let's see, 54 minutes. What was the tank blew up at 55, 54, 53. So 8 minutes, pretty close. So that's what that looked like. Okay. And this electrical power system, you can see we're charging battery B. The battery bus was up, it was over voltage, 1.12 amps on the battery charger, which you read 0 over done. We always kept the 3 little entry batteries topped off. We made sure of that. And you know, the main bus, DC buses are running about 29 volts, 25 was the minimum. AC buses are 115 volts AC. And all the fuel cell parameters here, here's the H2 flows, the O2 flows into the 3 fuel cells. Fuel cell currents, each fuel cells were roughly sharing the current. The fuel cell was capable of putting out 55 amps of current at, and keep the main bus volts up around 25 volts. Important. Equipment was made to operate at 25 volts or higher. So we had the pretty low, the fuel cells were all operating with less than half the capacity. Life was good. So that was nominal. What else did I tell you about that? Okay, I told you the way we had the buses set up, fuel cell 3 was feeding main DC bus B by itself. So when it died, it took all the equipment out that was feeding. And fuel cells 1 and 2 were feeding main DC bus A. So when fuel cell 1 went bye-bye, we still had 1 fuel cell on the main DC bus A. So the stage is now set for then our worst space disaster. Because no one could know that the cryogenic O2 tank wiring was severely damaged as a result of a poorly conceived, poorly executed detanking procedure on the tank. So let me take you through the tank set history. This is, by the way, this is in the back of the book too. You can follow the chronology of the tank set, those 2 tanks on the shelf. 1962, North American awards subcontractor ET Aircraft to design and build cryogenic storage tanks. Specs call for the tank heaters and fans to use 28 volts DC, which was our standard, our spacecraft standard. In 65, 3 years later, KSC launch facilities decided they would use 65 volts to DC ground power to reduce the tank, it's a procedure thing, reduce the time to pressurize the tanks during the pad test. However, there was a thermostat in the tanks that would cut the heaters off, the pressurization heaters, at plus 80 degrees Fahrenheit. Now, normally the O2 ran about minus 300 degrees Fahrenheit. And they were told in 66, years later, the tank manufacturer begins. It includes a 28 volt heater thermostat. And nobody was told to change the thermostat to a rating of 65 volts. So there's the first step. In 68, the cryogenic shelf, which I showed you, begins. It's slated for Apollo 10, by the way, not Apollo 2. Gene Cernan is quite happy about that. And let's see, later in 68, the oxygen tank shelf was installed. The service module 106 was the service module for 10. October 1968, when the O2 tank shelf was being removed by hoist from the Apollo 10 service module for mods, a bolt snapped and it dropped about 2 inches. Here it is cantilevered out. So bolt snapped, and the tank dropped like this. Probably pulled 70 Gs instantaneously. You don't know. And this impact probably, probably misaligned this fill drain tube for the tank, which is not used in flight. And it probably misaligned this loose fitting connection here is Teflon. Now you've got a leak point. So how many does that make now? Let's see. You had the thermostat sitting there waiting at the wrong rating. The loose fitting, that's 2. Now we got to drop it to make it real and misalign. And by itself, no big deal. But it led to that improvised detanking procedure on the pad that almost certainly set the stage of the incident. So November 68, subsequent testing revealed no discrepancies, although no testing of cryogenics was conducted. They probably used gas and they didn't detect anything. The required mods necessary to reassigning the O2 tank's shelf to a later mission, Apollo 13. So the mods took it out of the testing loop, and so it's okay, this is Apollo 13, no big deal. One mod was not accomplished, and that of changing the 28 volt tank heater thermostats to one with a higher rate to be compatible with KSC ground power, 65 volts. Here's I showed you the O2 tank. This is O2 tank 2. There's the fuel cell on the shelf above. So when this blew, it impacted these two. And of course, there's the 2 fuel cells up above it. So now you got that. June 69, the Apollo 13 service module was shipped to KSC for further testing and assembly on the launch vehicle and launch. Everything was checked out, mated, and March of next year, March 16th, getting close to launch in April. A major pre-launch pad test, the countdown demonstration test, or CDT, was conducted. This is an all-up test, and the only thing we did was fire it off, which always worried me. But it included filling the service module, cryogenic H2 and O2 storage tanks, and running the 3 fuel cells off them. Okay, so once we got done with that, with the big test, we would empty the tanks, or we should empty them halfway. And when they went to empty oxygen tanks 1 and 2 with gas, pure O2, tank 1 dropped down to 50%, tank 2 dropped down to about 92%. Something was wrong. What was wrong probably was that loose fitting, the fill drain tube, the gas was escaping out, and it wasn't going into the tank and really forcing the O2 out of it. So that was a difficulty, and we can blame that on that loose fitting, the fill drain tube. A week later, the detanking operations were resumed with a decision to try to boil off the remaining oxygen in O2 tank number 2. And the way we would do that, of course, is, as I showed you the heater core with the 2 little fans at either end, is turn those heaters on manually and leave them on. And and so that was the procedure they adopted to push the O2, to actually force the O2 out. And they were applying a 65 volt DC ground power. And the tank was emptied after about 8 hours of tank heaters and fan operations. The effects of it were disastrous. Here's what the thermostat did. When it tried to open it, the fuse closed. Too much current going through it. The tank heater thermostats rated for 28 volts were set to open up at a tank temperature of plus 80. Arc and was fuse closed and the switches attempt to open with the 65 volt ground KC power. Anecdotally, a technician who was monitoring the boil-off tank drain procedure was told to not allow the tank temperature to rise above plus 80 degrees Fahrenheit. However, his temperature gauge, was probably an analog gauge on his ground power panel, only read to 80. So it sat there pegged at 80 degrees for 8 hours. Allowing the tank temperatures probably to get over 1,000 degrees Fahrenheit. During this time, this is probably what happened to the fan wiring, the twisted pair fan wiring, which is Teflon insulation, and enough jar, and up there, short those 2 wires together, and now you get a spark, and a little bit of hydrogen, hydrocarbons, both the Teflon, in the presence of pure oxygen, you go with fire and explosion. Anyway, and this was done post-mission. Once we had all the data, those data, they could recreate all that. March 30th, 1970, was designed to test the oxygen tanks again by filling them, and the boil-off procedure was done once more. 8 years later, 8 years. The stage is now set for then our worst space disaster. We launched with a bomb on board. April 11th, of course, we launched Apollo 13. April 12th, the crowd tanks were stirred. By the way, I guess I should have showed you this. On the main display panel, here are the 4 switches. The H2 fans 1 and 2, O2 fans 1 and 2. And so when Swigert didn't throw the switch, he threw 4 switches for about a minute to stir the crowds. That's what he did. Anyway, so April 13th, at the beginning of the last hour of my shift, I requested an extra crowd stir before they went to bed to obtain a good reading on O2 tank 1 quantity. The stir commenced at 55, 53, 20. At 55, a few seconds later, the tank blew up. Now, I've had some people argue with me, some space geeks say, it was not an explosion, it was a rapid expulsion of gas. I said, well, how fast was the expulsion of gas? Anyway, so let's see what we have here. Here's the ECS cryo cabin unit. We have a fire in the tank now. I just have to cut this data point. What you see here is O2 tank number 2 starting to overpressurize, 996 psi. O2 tank 1 is dropping. So the tank probably is the top is already starting to blow off. The pressure has dropped down, O2 tank 1 was leaking. And that's where we stood with that. Electrical power system, we were done charging the battery, and there's nothing showing up yet. There's a lot of inertia, and when you're going to kill a fuel cell, they have, if you shut the feed valves to the fuel cell, then less than a minute. But under a situation like this, 1 minute felt like 1 second. So next thing I looked, they were gone. So we're okay there, and we still have the master alarm sounding from the where is it? Well, I can't get it. Master alarm from the low pressure nitrogen tank. We're still quantity balancing. Okay, so we got that. In the meantime, it didn't make a difference. We still had the master alarm was sounding, and the cryo press light was a big orgate, and it was already locked up, lit, so it didn't tell the crew anything. I told my backroom guys, my SSR guys, staff support guys, I said, look, we don't know when the crew are going to do it. We have no telemetry on the switch positions. And the cryo O2, cryo H2 behave in different ways. So I said, I'll watch the H2, and you guys watch the O2 settings in the back room. Because the O2, I think, would drop in pressure, the H2 would drop in quantity, it would let it get stirred back up. Little I know, they were all looking at the H2 parameters. They didn't do what I told them to do. So the next time we look, the tank's blown up and the data's gone. So there was a fire raging in O2 tank 2, and soon it will fail. I'll show you those a little bit later. So let's see what's happening. The crew had terminated the battery recharge, like I said, and everything looked pretty normal in the electric power system, but the spacecraft is now kind of jacking around. And the crew reported that they had a problem. Here's the other part of that.
That's kind of looks like the last item we need here is a stir of the H2 and O2 at their convenience. We got one more item for you when you get a chance. We'd like you to stir up your cryo tanks. Okay.
That's it.
Hey, we have a problem here. What's the matter with the data you got? Just say again, please. Oh, you're coming up. Okay. We got more problem. Okay,
That wasn't fun. Anyway, that's how it kind of quickly happened. And it was about this time that I discovered that denial was not just a river in Egypt. because we were not trained to have the oxygen tank blow up, take out a whole bunch of equipment, a whole bunch of data. We would say, well, that's probably instrumentation, like we did happen on Apollo 12. Apollo 12 was easy. We just had to throw one switch to brought it all back. Not in this case. So the crew, of course, the famous words, Houston, we've had a problem. Past tense, right? Ron Howard put it in the present tense, because I guess he felt it was more dramatic. I always like to talk about, I'm sure there's a book written, certainly is, in which you would put this saying, or there the movie saying, I didn't say that, and that would go in there. It turns out there is a book written like that. I didn't say that. Anyway, so what did I look like when I started out this whole thing? I look like that. Yes, we really did, Martha, look like that. And I think I ended up looking like that up to the challenge, of course. Where this cartoon came from is a friend of ours, mine, who worked with Mike Collins, and his son is an artist on site. And I said, Mike, I need a cartoon of a flight controller. He said, my son's an artist. Why don't we give him a call and he'll draw you one up? I said, okay. So I called, his name is Mike. I said, he said, what do you need? I said, well, I need a cartoon of a flight controller for my talks. I said, what's he look like? He's got a buzz cut, he's got dark boardroom glasses, got a headset on, he's got a white shirt, short sleeve white shirt on, a little collar, slim Jim tie, and a pocket protector in his pocket with a bunch of crap in it. And the other was silence. You can tell when somebody's thinking. And a couple seconds later, he comes back and he goes, oh, you mean nerd. Yep. Anyway, that's the story about that. And but seriously, this is what the whole looked like. All right. So the tank explodes at 55, 54, 53, right? So this is a few seconds later. And what you can see on the ECS, this is tough to do this way. I'm usually up there. So what you can see here is the telemetry O2 tank number 2, down here at the bottom, is reading nothing. 19 is nothing. Because what happened was it blew everything out of it. And O2 tank 1 now, normally 900 psi, is dropped quickly down to 782 psi. Okay, and that's what's happening on that one. And so this is a few seconds after the tank blew up. All right, so now let's look at the electric power system. Well, nothing's showing up in the fuel shed yet because they're not dead yet, but they are. But it's starting to show up in the flow going into the fuel cells. Because what happened, shock of the explosion hit the shelf above and shock closed the valves of the O2 and H2 feeding into the fuel cells. And we had no telemetry on these valves. We didn't know what the hell happened. All we knew that we didn't believe what was happening with the fuel cells. They were dying. So the stuff just started to show up a few seconds after the explosion. And you note down here that the signal strength when the high gain antenna got hit got real bad, real low. Let's see what else I can tell you about that. Okay, looking at probably 50 parameters that were non-nominal. And I said, we may have an active instrumentation problem. This has haunted me forever. Probably the greatest understatement in the history of manned spaceflight. It was not. And this is kind of what it sounded like. I didn't get the clue.
Okay, listen, you guys. We've lost fuel cell 1 and 2 pressure. We lost O2 tank 2 pressure and 10 pressure. Okay. Stand by, I got problems here. Okay, flight, we've got some instrumentation devices. Let me add them up. Okay, stand by, 13. We're looking at it.
That was a little tense. Panic is interesting. It comes up like this, like a gorge. And you either fight or it's flight. You learn to push it down. And I hate that trite saying about, and then the training kicked in and BS. Training is already done its deal. You learn discipline, you learn to work the problem, and bring your emotions under control, and you work the problem. And I didn't sound too trite about that. That's pretty much what you do. What choice do you have? Get up and go home? I'll admit it didn't. That thought didn't go through my mind. Not an option. But see where we are. Less than 2 hours remained of life came out. It was 3.5 minutes later, it was all over. Look what's happened now. O2 tank 1 down here is down from 900 psi down to 377 psi. Of course, O2 tank 2 is done. And then electric power system, fuel cell 1 is dead, fuel cell 3 is dead, and fuel cell 2, fuel cells had a capacity they could pump out about 55 amps and 25 volts DC. It's pumping out 53.4 amps up here at 25.27 volts. It's on its knees. And about that time, Fred Hayes put one of our precious entry batteries online to beef up the bus set. But there's where we stand. We got 2, 3 fuel cells are dead. And look what happened. Main bus B was fed by a single fuel cell, number 3. It's dead. It's feeding alternating current. Bus number 2, it's dead. And this whole thing cascaded through everything. And then you can see down here that flow rates into the fuel cells are now dropped off. And fuel cell 2 is taking 92% of the total spacecraft load that was left. Not good. So, what did I say?
Flight econ? This is go-econ. Problem. We don't know the cause of the problem. Flight, I've got a feeling we've lost 2 fuel cells. I hate to put it that way, but I don't know why we lost them. It doesn't all tag up. And it's not an instrumentation problem. The best I can tell right now.
Still denial. So that's where we stood. So to me, I was looking at nearly 50 parameters that would look like they're simultaneously out of limits. And it was no wonder, and I'm not making excuses here, it was no wonder that my initial reaction was to suspect a huge instrumentation problem or failure, as I witnessed when I was sitting next to John Aaron launching Apollo 12. And stupidly, I said so. Because it was not an instrumentation problem at all. And there's no takebacks, by the way, in our business. as long as my peers live and I meet with them occasionally, they will always remind me of what I said. What do we call it? A gotcha, I guess, in some of the astronauts. Okay. So, what we did some more post testing, and we said, well, how big of a bank was that on that panel of, let me go back. See that? Whole panel of the spacecraft blown off. Here's the 2 fuel cells just above. O2 tank 2 was here. And we didn't dare use the big engine because we didn't know what damage was done internally to the tankage. And so we said, got to use the wise decision to use the lunar module. There's more considerations than that. Lunar module descent engine. Thank you. And by the way, let me tell you something. Sometimes when flight controllers are asked what the most significant mission was to us, and we will always say, those of us that say, Apollo 8. And they go, ooh, why Apollo 8? How about Apollo 11? Because Apollo 8 was the first time we went to the moon. We didn't have a lunar module, by the way, in retrospect, thanks to light. That was a guts mission, because all we wanted to do was beat the Russians, and we did. So that's why we did that. Apollo 11 was the culmination of a set of engineering tests. Apollo 9, Apollo 10, Apollo 11. That's what we did. Be careful about that. Anyway, so this is what happened to this booger. It was really goner. And so we did a test. The engineering community did a test and said, okay, we're gonna fail that tank again, and let's see what happens. Well, guess what? They figured out that the oxygen tank had exploded with a force of 60,000 psi, 4,000 times the pressure in this room. And a gee whiz number is probably equivalent to about 7 pounds of TNT, which is enough to level a 3,000 square foot house. I remember doing this kind of talk over in Germany, and I had to convert everything to the metric system. So it was a rapid expulsion of gas, just like this guy said. And so the next 2 hours were filled with successive equipment power downs. Because one of the things we had to do is make the remaining fuel cell supply of oxygen last. So we did. We kept powering space. We had pre-arranged power down steps we could tell the crew to hit it on board. And like the first thing I said, I got to power down to 10 amps, so I tell the flight, have the crew go to the emergency power down list, steps 1 through 6, or whatever it was. And that'll give us about a 10 amp power down, and we reduce the load on the remaining fuel cell, that is consumption of oxygen, and we can keep it going until we got the LEN power up. That's a booger. That was a real scramble to do that. So that's what we did, and one of the things we had to do is we wanted to transfer the state vector knowledge in the Apollo guidance computer over to the sister guidance computer in the lunar module. And we had to do that before the command service module died. And that was a real scramble to get that done. The knowledge of where it was in time and space and all that. That's all double E knows about guidance. So that's what that looked like. And then I said, to my pride,
the pressure in O2 tank 1 is all the way down to 297. We better think about getting in the LEM or using LEM systems. I'm going to have to power way down. I don't know if I'm going to be able to save the O2 for the third fuel cell, for fuel cell 2 rather.
46 minutes. It wasn't the FIDO, it wasn't the lunar module guys, it was the EECOM that said we better get in the lab. Of course, everybody else is thinking that anyway, so that's just a credit for it. So, what was this malfunction? It's probably best characterized as a cascading multiple systems failure, resulting in quadruple or more failures. It would be a long and dangerous flight home. So, lastly, that's not bad, it's 1 hour. We did it. Let me show you a picture of the luckiest astronaut in the world. Ken Mattingly. He was bumped like 3 days before the mission because he had been exposed to germ measles by Charlie Duke, who then he called Typhoid Mary. And the argument was that it's not that bad of a disease, and he's fully trained, let him fly. No. Turned out that Chris Kraft made the decision. And at the time, Ken strenuously objected to the decision, which is much more philosophical about it. He got reassigned to Apollo 16, which was an eminently successful mission. So that worked out pretty good. So he's not too unhappy about that. So we have time. I'm going to give you some funnies. Apollo 13 coincidences with the number 13. So always somebody can do this. And we were blissfully unaware of the coincidences of the number 13, Apollo 13. So here you go. Apollo 13 left off pad 39, so the multiple of 3 times 13, I know. It's 13 minutes after the 13th hour in April. If you add up all the numerals of the launch date of 41170, they add up to 13. The accident took place on April 13. There were 13 letters in the phrase German measles, the illness that grounded Ken There are 13 letters in the names, James, Fred, and Jack, first names of the crew of Apollo 13, and the horoscope for Aquarius, which is the lunar module's name, Aquarius. This is from the Houston Post, which is our never down one newspaper. We had 2 back then. The Houston Post horoscope for Aquarius on April 13, 1970, said in part, do surprises turn you on? And this is the day for the unexpected. And I tried with the words Apollo 13, it came out with 14 letters, all that stuff. Got to pick and choose. Anyway, I'll be glad to answer any questions you may have. This is out. I found that when I talk to undergrads who can't relate to Apollo 13, they don't have any questions. They don't ask anything. So I have to invent questions for them and then answer them for them. And that happened. I was talking last week to the co-ops, the spring co-ops, and I told the lady who was organizing them, I said, "You're not going to be any questions?" No, and there was no questions. And I sat them in the old locker so that they get the feel for the consoles and all that. No questions. The best questions I ever got, I was doing a talk for some IT people up in Chicago, and they're all adults and they're all technical. Boy, they asked me some questions that really were great. And one of them I couldn't answer. They said, "How quickly did you make all the decisions? Like free return back to Earth?" And I said, I don't know. I just never thought of it. It was quick. It was one day. So I ran home and put up a slide. It's good. We did a lot of decisions very quickly. Very quickly. Some of them it was a no-brainer. But typically Ron Howard over-dramatized that. He also over-dramatized that the crew never got into a fight with each other. That's BS. There's no dissension. I mean, Fred Hayes was very ill, and everybody did their job. And so, in fact, I specifically asked Jim Lovell about that. That was just for the movie. They gave Ken Mattingly more credit, God love him, than he deserved for the command module power-up procedure for entry. That effort was managed by John Aaron, my brother Econ. Brilliant. I was told one day to get over resenting John Aaron because he was so smart. So I wouldn't be the first one to ever have an inferiority complex about somebody that's smart. But he managed that power thing, and like Ken said, he said, I was just a monkey. They gave me the procedure, and I jumped in the simulator and threw the switches because he knew where the switches were. So, and it was things like that in the movie that it was okay. Bottom line is that movie, 1995, regenerated, like I said earlier, the interest in our space program, and also gave a lot of us the impetus to get out and talk about it. And some of us got paid, not tonight. But it turned out to be just an incredible piece of work that he did. He managed to take what PBS did in 1994, a terrific documentary, and convert it into a drama that still had a degree of suspense to it. That's incredible. And anyway, so I get a chance in some of my other talks to point out the artistic license that he took. Anyway, are there any questions that occur to you? Yes, sir. I'll run up.
Yeah. When was the crew members debriefed of this sequence of events that led to the explosion? I asked the Jim Lovell, wasn't that somebody dropped the tank that was the cause of the explosion? He said that no, what he knew was that the thermostat selection was wrong. That's what he replied to me.
Well, I tell you, one thing that Fred Hayes told me recently, he said the one thing that they didn't do that they could have done a better job of, they knew, because they saw the physical manifestations of the gas escaping and the spacecraft moving around. He said they didn't do a good enough job, he felt, of telling us on the ground exactly what they were experiencing. Because we were just watching data, or the lack of data. But Jim, you say, when did he know, or when was he debriefed about that?
Yeah, on the ground.
Well, they got home pretty quickly. So the debriefings normally took place pretty quickly after they got back. But remember, they could only, when they debriefed them, they could only say what they experienced. And of course, then we have our experiences on the ground. And when that was all put together, and especially after the spacecraft testing, with the data, once they got the real data back, the real fine-grained data, they could see the little glitches of current that we couldn't see because our sample rate was so big. And they could recreate tests and recreate just what happened. And I tell you, it was kind of scary. It was just, Jim Lovell said to me one day, we were at some book signing or autograph session, he says, you guys saved our ass. And I got a grin on my face, did we? It's kind of nice, because a lot of the astronauts just considered us flight controllers who were passionate about crew safety and mission success, by the way, to the detriment of some of our marriages. They just considered us part of the vast infrastructure on the ground that comprised the big spear that they were at the very tip on, aimed at the moon. And we objected to that, because we considered ourselves ground astronauts, much to their chagrin. But we were pretty cocky, and everybody was pretty collegial. We drank a lot of beer back in those days. I understand that tradition hasn't gone away, at least in college. But there were some grand times, and you'll read about my book. How's that for a segue? You'll read about, it's not a big book, about half of it I teach you how to be a flight controller, and I also give you some anecdotes, not somebody else's anecdotes, my anecdotes. There are people that write books, it turns out, about other people's experiences. These are my experiences. I take several characters like Chris Kraft and Gene Kranz and Neil Hutchinson, and I talk about them, what I liked and what I didn't like. It's not a tell-all book, it's just what my experiences were. Chris Kraft, for example, he's very autocratic, and he had a way of doing things. So it's his way or no way, by the way. And he would, if I met him, pissed him off, he would call you young man. And if he called you young man, your career was over. You would never get promoted ever, ever again. That was his way, and I pissed him off all the time. Fortunately, I had a branch chief that saved me, so I did get promoted. But he did that. He'd be in a senior promotion board, he said, oh no, we're not going to promote the guy. No, he pissed me off. So, just because I was a little bit zealous on Apollo 4 as assistant flight director, you just don't do that to Chris Kraft. So I got a chance to do that. You'll read some inside stuff. You'll read some inside stuff about the Singing Wheel, which was our bar that we went to. You'll read about Streaking Webster. jumping out a window, naked, and rolling off the little roof and racing the Webster Cox back to the second wheel, and stuff that, you know, the in the trenches flight controllers did, that the flight director, you know, when Gene Kranz read his book, he could only take it down just so far. He wasn't with us when we really got wild. Because he's a good Catholic, he didn't do that. But we did, we were younger. So you read a bunch of that stuff, and you'll see, with respect to this technical discussion, all the screens are in there, the chronology's in there, and you can relive it, and if you want to, like the Space Geek guy who, that's an affectionate term, by the way. He said, you know, I read Si's book, and then I put the CD on, and I lay back on the couch, and he says, and I was there. But I'm happy. I mean, I just love it when people are willing to relive it with me. And you guys give me an opportunity to live in the past again. That's why everything is so clear in my mind. And I had a real problem with a BBC reporter. He called me up. He was doing a newspaper article for the London Times, and he had errors in there. And I said, no. He had one thing there. He said that it was Charlie Duke. He sent me a copy of the transcript, NASA transcript. Charlie Duke was sitting next to you, telling the crew to stir cryos. No, it was Jack Lausman. The transcript was wrong. Oh no, the NASA transcript did not wrong. So I'm going to send a copy of the picture of the motor I showed you. Exactly. Liebergot, Lausman. I sent him a copy of the clip, the audio clip. He said, I still can't believe that's wrong. I says, NASA is wrong. I was there. Now you going to correct the article or not? Charlie Duke was not even on the mission. So I had to go back and check all the mailing lists and tell misconceptions. Keep going. And I said, well, who do we talk to get the NASA transcript talk? I said, correct. I said, good luck. Good luck. Yeah, I went back and checked it. Charlie Duke was never on Apollo 13. He's on Apollo 11. Yes, sir.
You mentioned Vince Grant earlier.
Who?
Vince Grant.
Oh, Vince Grant, yeah.
Yeah, what was his role at the time?
None. He had no role in that mission.
Well, he was an astronaut.
Oh, sure, yeah, he flew, and I write about Vance. He's one of my favorite people. Vance was command module pilot on this Apollo Soyuz, ASTP, and it was his job to enable the Earth landing system, which the crew always made sure was disabled. Somehow the two switches were not enabled, but he had the presence of mind watching the altimeter to punch out the stuff manually, droves, whatever. And of course, because of that happened, the jets weren't shut off, and we got hydrazine, essentially, RCS fumes into the cabin, which is very corrosive to your lungs. And they were dying. And Tom Stafford, being the commander, had the presence of mind to get the oxygen mask out, but those guys really suffered some damage. And that didn't help a bit in the mission dead. But, and so what I did for Vance was I gave him, I had a little walnut plaque made with the two switches on it, and gave him, and I was criticized by my division chief at the time, Pete Frank. He said, you shouldn't do that. And I said, why? You can't laugh about it. What good are you? And so I roasted him. Vance turned out to be pretty good. I called him Humble Brand because he was a very humble guy. She was, I'm sorry, I didn't mean that thing. He was kind of like that in character. But he had no role on the mission, other than sitting there. That he gets cropped out, by the way. That unfortunately, that picture gets cropped where you don't even see Jack Lausman with the Capcom. So I make sure when I found the full version of the picture, make sure I show you guys that so you can see how empty they are. In fact, John Young was being interviewed for an autograph session one time. He did some video clips, and they asked him where he was for the Apollo 13. So I was standing right behind side. And I remember grabbing him by the shoulder and saying, "Boy, that sure don't look like an instrumentation problem to me." then he said, and I know Si probably have something to say about that. And what I submit to you is that picture of the motor. It's nobody here. And I just commented, I said, you know, that I said, John, memory's a tricky thing. You gotta be careful about that stuff. But he showed up later. At one point, I did a voiceover for this Mark Gray's TV stuff, the movies. He did a thing on Apollo 13, multiple DVD thing. He asked me to do the voiceover for the control center shots. And I was really surprised to see all that stuff. And one of the things I noticed was that, which I didn't notice in the still shots, was that when the crew stepped out on the deck of the carrier, that's when we got excited, the recovery carrier, I was doing the voiceover and I noticed the handshaking going on. And I noticed, and I know this sounds like sour grapes, that all the managers were congratulating each other, and nobody was from that level was congratulating us. So I guess that's how it goes. Take your self-satisfaction and go home. But it was, and there's always a lot of doubt about why did I'll answer the question for you. Why did the blackout last more than 3 minutes? Why did it last up to 6 minutes? Actually, it lasted, by the transcript, it lasted almost 7 minutes. Just about 7 minutes. And the answer came back from, that I asked our ace retrofire officer, Chuck Dietrich. And Chuck said, well, we probably came in a little shallow. And I looked at him and I said, at 25,000 miles per hour, a little shallow is a lot shallow. You just don't need to. But then there are the people that disagree with that. France doesn't agree with that. The aiaa aircraft, was a communication aircraft, could have been out of position a little bit so they didn't get acquisition till later. They're not willing to accept what the original flight officer said. They know better. So I got dirty looks when I said that. I was at the Cosmosphere and I said that. I got dirty looks from a couple of guys, Jerry Boston. You know what you're talking about. So, any other questions? Yes, sir.
I think we have time just now for one more.
Okay, well, I got one.
And then Si will be available after at the table selling some books.
Yeah, I'll tell them.
Immediately after the situation, found that the explosion, you got over your head.
Calm down.
When you first thought you started to handle the situation, what chance do you think the chances of getting the crew back?
Never a doubt. No, never a doubt. I mean, our discipline is to work the problem, and there's no doubt that we'll get it that way. Why would we be doubt? We did have one Fido, when he was asked, he said, oh no, most of us didn't think we were going to get it back. That's BS. None of us thought that, except him. Of course, if you met him and saw how dour and sour his attitude was, you'd see why. But no, we never, and I'll make that too. I will take a polygraph test. We never considered that we could not get them back. Had too much go for us, right, Jack? Jack was on lunar module with EECOM.
I mean, what I can tell you is there was a lot of things that could have gone wrong. And then it get back, but we were never going to give up trying.
Right. That's probably a better way to put
Everybody
it.
had their private thoughts about it.
Never gave up trying. We would have kept trying until they skipped off the Earth's atmosphere and went into a 4-month orbit. That was one of the things. Yeah, that's a good way to put it, Jack. Never gave up trying. What we'll do, I'm going to go to the table here. I've got about 50 copies of my book. And if you all like to purchase them, I'll be glad to do that, sign for you. They're $20, drive out. And I'll take the check or cash, the negative. Or if you have anything else for me to sign, I'll do that. Okay?